Hello, this is Mr. Kenyola, and I'm going to show you how to convert degrees into radians. Now, if you remember, a full rotation in degrees is 360 degrees, and radians, full rotation, the distance around a circle in radians would be 2 pi. And so what we'd want to do is, because this is 210 degrees, your answer wouldn't be 2 pi because it's not a full rotation. We want to get a fraction. What fraction of 2 pi does 210 give us? So typically, what you would do would take that 210 degrees and put it over 360 to get a fraction and multiply it by 2 pi to get that partial distance around the circle. But before we do that, I'm going to simplify this process a little. I'm going to put an x over here, and this x is going to represent any degrees, any rotation. And I'm going to put a 1 over here and make this more like a degrees symbol, and put a multiplication right here. Now, if we multiply this by this, before multiplying that, we can simplify this. So if there are any numbers here that we can cancel out, this 2 and the 360, if we divided both the 2 and the 360 by 2, this 2 would cancel out, and this 360 would turn into 180 degrees. And then this would turn into x over 180 and pi. So let me separate this a little and make this equal to x, okay, times pi over 180. So this, I took this part, so I just put a parentheses around this to make it look like this. So this right here, simplified, is your formula to convert from degrees to radians. So if you want to put this in your notebooks or make a power card out of it, okay, degrees to radians, you take that degrees that the problem gives you and multiply by pi over 6. But if you don't want to do that and just go the 360 degree route and multiply it by 2 pi, you can do that. You'll still get the same answer. But we're going to use this formula to convert 210 degree rotation into radians to figure out that distance around that circle. So 210, we're going to plug in for x. So 210 times pi over 180. And I'll just put a 1 under that. And let's simplify that. Let's take our calculators. It might be getting late for you, so you may not want to think too much. So let's use our calculators, and let's type in 210 over 180. Let's press enter, and that will give us 7/6. And so our answer would be 7 over 6, and don't forget that pi. So the 210 over 180 simplifies to 7 over 6 and times pi. So there is our final answer to convert 210 degrees into radians. So the distance, if we rotated 210 degrees, would be 7 pi over 6. Let me give you 2 more examples. This time, negative 120. So you're wondering, wait a minute, we haven't seen negative numbers in the unit circle. Well, if you remember the unit circle, it traveled this way, okay? So a negative would just mean that you would go this way, okay? And so you want to convert that into radians. Same procedure, same formula. You take the negative 120 and multiply it by pi over 180 degrees. And you can put a 1 under that if you want, and you would take your calculator, and if you have this great fraction function in your calculator, you just press that fraction button. Otherwise, you just have to manually simplify negative 120 over 180. That would turn to negative 2/3. And don't forget the pi. If you forget that pi, then the whole answer is wrong. So, negative 120 degrees to radians is negative 2 pi over 3. Now look at this gigantic number, 615 degrees. Okay, that just means that it rotates. The rotation is greater than 360 degrees. So it goes around and then it goes around even more. Okay, so to 615 degrees. Our goal is just to convert it to radians, so we just take that same formula, 615, and multiply by pi over 180 degrees. We'll put a 1 under there. If you have your trusty calculator, you press that fraction button, and you type in 615, and you divide it by 180, and that would be 41 over 12. 41 over 12. Actually, 41 pi over 12. And there is your final answer. And that's how you convert degrees into radians. Just take the degrees and multiply by pi over 180 and simplify these two numbers. There you go. Hope that helps. Have a great day.